So the three measures of center are, what's one measure of center? Mean, median, mode, the three M's, right? So your mode is always your most frequently seen data point. The median is the middle, and the mean we always talk about is basically the average, yes? It's another word for average. Okay, so we're going to talk about each of those kind of in detail. So the first one, the mean, you add them all up, divide by how many there are. We've done this since you were little. They will use this notation. The sigma notation means the sum of all the extra data points. Okay, so know the notation. The population and sample have two different, and you have a U or an X with a line over it. So the population, the entire population average would have that little U and a capital N in the, and that's the population mean.
What?
We're recording. All right. The sample one has the X with a line over it and a little baby N. Okay? You do the same thing. You're going to add them up and divide by how many there are. But that would indicate which one you're talking about, whether you're dealing with population or sample. Okay? So understand, when you see formulas like this, you need to understand what that says. Add up all the numbers, divide by how many you had. All right? All right, so find quickly with your calculator, so for you have a calculator here, find the mean of this data set. All right, you guys, the sum of the x's divided by, how many we got here? 7? So you should get 1810 divided by 7, which is approximately, please understand that symbol, which I know you all know it, 258.6. So it's an approximate mean because it's not exact, we're rounding. Okay? We good. And this is a sample. Right? Okay. Median is the middle of a data set, but important, the data set has to be in numerical order. Okay? You're just going to split it into two equal parts. The median is the middle of that split. So sometimes there's a number there. If it's an odd number, there'll be a number in the middle, and that's going to be your median. If it's an even number of data points, your middle is going to be between two numbers, in which case you have to find the average. Okay, so depending on whether it's even or odd. So let's look here. The weight in pounds for a sample of adults before starting a weight loss study are listed. What is the median weight of the adults? So there's 1, 2, 3, there's 7. So is it 268? No. Why? It's not in order. Okay. So if I put them in order, is it 268? Yes.
Oh, you got it.
Shut up. Was that good or not? And what's really weird is I didn't even notice that until I did that. So this is the middle regardless, but you have to put it in order because it's not always. All right? So 268. Okay. Assembly plot. What's the median? So first you have to figure out how many there are. Some people do this. Cross out, cross out, cross out. Craziness. 1, 2, 3, 4. There's 6, 10. There's 14. What's half of 14? 7. So we have to count 1, 2, 3, 4, 5, 6, 7. And you can double check. 1, 2, 3, 4, 5, 6, 7. So we're between two numbers. So 70 less 75 divided by 2. So 72.5. So sometimes the median is not in your data set. Sometimes it's between 2 points on the data set. Okay? Other thing when you're dealing with stem plots, make sure you're always counting from the inside out. So don't do this. 1, 2, 3, 4, 5, 6, 7. Inside out from the bottom, okay? Or the low number. All right. The mode is the one with the greatest frequency. If there's nothing repeated, there's no mode. If there's more than one that have the same frequency, it's considered bimodal or multimodal if there's more than two. Okay. So, here we go. What's the mode? The mode is 10, right? Has the most frequency. What's the mode? Dogs. So you want to answer with what the category is, not what the number is. Okay? Sometimes it gets a little confusing. Now what's the mode? Dogs and hamsters, so it's bimodal. Okay? Alright. Outlier. We kind of talked about it yesterday, right? Outlier is a point or more than one point it could be that just doesn't seem to belong with the other data points. Okay? So if I'm looking at a scatter plot, you might have a point floating out here. This is a box plot, which we're going to talk about tomorrow, I think. It's floating way at the high or low, or a dot plot. Okay? So it's going to be either a min or a max number. All right? You could have 2 up in the upper range or 2 or more in the lower range, but it's one that doesn't seem to belong. Nobody gets, okay, it's okay. Right? Okay, moving on. Guys aren't thinking I'm funny. Here we go. Top grossing movies in the box office in 1994. Do you see an outlier or possible outliers? The bottom 2, right? So this is 299 million and 300 million. Any guesses? 1994, and I know you guys were not around.
Yeah. It's fine.
Huh? These are both going to be outliers. The Lion King is one. That's a top grossing movie in 1994, Lion King. And the other one is?
Home Alone.
Forrest Gump. Forrest Gump. Forrest Gump and the Lion King. All right, but those are outliers. So we got it. We're going to talk tomorrow, the next day. We're going to actually calculate outliers and tell if it's a true outlier, if it just looks a little bit higher than normal. Okay? Okay, weighted mean. So this is important for you to know because you're graded as a weighted mean. Okay, so our CCP stats grade weights. Homework is 15%, projects is 15%, tests is 45%, and your final is 25%. So at the end of the semester, notice it's got the sigma notation, X times W. W is the weight. Okay, and you have the sum of the weights on the bottom. This is also how you find your grade point average, which we'll do an example like that as well. So at the end of the semester, Bob has the following grades. Homework's 95%, projects is 82, tests is 85, final exam is 64. And what is his weighted grade? So we're going to do 95 times the weight, which is 15 for homework, plus 82 times the weight for homework, or projects, I'm sorry, 15. Test average times the test weight. Final average times the final weight. Who has a guess as to what Bob has? Looking at his grades, what do you think? He's got a 95 on homework, 82 on projects, 85 on tests, and the final exam was 64. Think of B? C? What do the weights all add up to? Should be 100, right? Okay. Go ahead and put that in calculator. Tell me what Bob has. Okay, so our total, our top, divided by our bottom. Oh man, Bob made it by the skin of his teeth. He's got the B. Okay? Alright. So, figure out his grade point average. So this is a little bit different. They have credit hours, and then when you get up into college, your grade point average, if you have an A or an A minus, it's different. It's not all 4s. Okay? So you have the plus and the minus in college. or in other schools actually. A lot of schools have it too. But so here's your grade point scale. So if I was starting this, I'm just going to start it for you. My English comp has 3 credits. Let's do the grade first. His B plus is a 3.3. The weight is 3 credits. The weight is your credit hours because you're getting 3 of those. Does that make sense? And then go. Plus your C times 4 plus your A minus times, and you're dividing by the total credits. So figure out what the grade point average is here. Okay, so our total for the numerator is 53, and we're dividing by 16 credit hours. And you get 3.31. 25 if you want to go crazy. Okay? So that's weighted mean. We all know how to do that. Okay. Moving on next. Mean from a frequency distribution. So if I give you a frequency distribution, to find the mean, you're doing the sum of each x times its frequency divided by the n. And remember, this n is your total frequency. Or you can do the sum of the frequency. It might be better to write it that way. Okay, that's what n equals. Okay, so if I'm working on this, I multiply 10 times 3 and get 30. Multiply 5 by 11 and get 55. 24, 26, 14. So you have to multiply each x times its frequency, because if you actually were listing those all out, you'd be adding them all up. So I get 149, and then what's my frequencies add up to? 13. So you get approximately 11.46 as your mean. Let's figure out, because we have this frequency table here and we didn't do an example like this, what's the median? So how many total do we have? 13. So what's half of 13? 6.5. So you have to go to the 6th and go to the next number, right? So if I count these up, you have 3, 8. So it's got to be in here. That's the median. Because there's 5. One of these would be on the lower part. 3 of those would be on the upper part. You'd have 1 left in the middle. Okay? Does that make sense? Okay. All right. Grouped mean average. So this is more like the relative histogram, put it in class kind of things. This distribution table is just single numbers. This one is you're talking about groups, intervals, class intervals. So if I still wanted to find the average, again, the problem with this is you don't know what numbers are actually between 8 and 11. They could all be 10s, right? Or they could be an 8 and a 9 and whatever. You don't know what all this is. So we're going to use the midpoints. You are estimating this mean. You're estimating. Okay? So you got to figure out the midpoints of your classes first. And then you're going to use the midpoints with the frequencies and find the table mean. All right? Because you don't know what actual numbers are in these class intervals, you've got to use the midpoints. Right? Are you guys doing that? Figuring it out? So we add them all up, you should get 171. Divided by 18 is 9.5. 9.5 cups of coffee. All right, and again, we're estimating. So we don't know exactly how much is in each interval. Yes, sir.
I don't know if it was coincidence, but I just added up the midpoints and divided by the number of classes, and I got 9.5.
Yeah, that is completely coincidental. That's also the midpoint of, that's also the, the median of this too, so that's coincidence, yeah. Okay, it shouldn't work that way. It just happens to have, there's 5 on this side of it and 5 on this side of it. Okay. All right. Okay. Find the mean, the median, and the mode of this table, please. 78,000 for the mean, median 65,000, mode is 65,000. So why are they not the same? Why aren't they closer? Any ideas why they're not closer, the median and the mean? Yeah, it looks like there's an outlier, right? So if they put in the paper that the average salary of this company is $78,000, that's true, right? But is it a true representation of the data? So sometimes a median would be a better representation than a mean. So then they can come back to you and we come back and say, well, the median salary is $65,000. We need a raise. Okay? That's the same as you're looking at a school and you say the average salary of a school employee is such and such. But they're not counting in the fact that superintendents make a lot more than teachers do. So there's that outlier that pulls it up slightly. Of course, there's a ton more teachers, so it doesn't pull it up very much. Okay? So, median, mean, sometimes use one, sometimes use the other. Sometimes they put one to distract you from what actually is going on. Okay? All right. Do we need to do this one? Okay, these are ages in a classroom. Okay? Notice anything weird?
There is not a lot. Very old.
There's a very old person who might be the teacher, let's keep in mind. Just said ages in a class, doesn't see the students. So this guy appears to be an outlier. So which is going to be higher, the median or the mean? The mean. The mean will be pulled up higher because of that outlier. So a better representation of this data would be a median as opposed to a mean. Yes? Okay. That's a graphical representation of that. So you can see the mean's going to be considerably higher. Not a lot higher, but a lot higher than this. Okay? That outlier pulls it, makes a big gap. Okay, I would write these down. Or you don't have to sketch the whole graph, but know the different ones. Symmetrical distribution is kind of obvious by its name. You can fold in half. If you draw a line, it's almost the same on both sides. So I can draw a line down the middle, and it's going to be kind of the same on both sides. That's what symmetrical means. Okay? If it's uniform, all the frequencies are pretty much the same. You've got almost a rectangular shape. All your bars are very close to being the same height. Okay, the next and last two are skewed distributions. So if it's skewed to the left, and this is people get confused all the time, that means the tail end, the low guys are on the left side. It doesn't mean the bulk of the graph is on the right. It's actually the bulk of the graph is going to be on the right. If it's left skewed, the little tail will be to the left. The mean is to the left of the median. So if you have any kind of outlier things, it's going to be on the left side. If it's skewed to the right, that means you have low points on the right side that are skewing the mean to the right of the median. So when they say right and left, they're talking more about how the mean is being pulled than what's the big tall guys at, where the big tall guys are at. Okay? So on a left skewed distribution, you have low guys that are pulling the mean to the left. And on the right, you have some low guys on the right side that are pulling the mean to the right.